Okay, we're going to take a look at kind of dealing with our primary trigonomic ratios, which is a fancy way of saying sine, cosine, and tan, something you're going to get very, very familiar with very quickly. So basically what this is if we have any right-angled triangle, like this thing here, we can figure out a whole bunch of things about that triangle using something called sine, cosine, and tan. So what that is, sine is our first one. So sine of our angle, and we'll just call it angle x, like this one here for now, is always equal to our opposite over hypotenuse. And remember, we did a really good job of labeling this stuff in our last lesson. So for instance, if I need to label it in this triangle, well, we know that this is my hypotenuse, it's opposite my right angle. If we're looking at angle of x as our angle of interest, this is opposite, and then this is our adjacent side. Okay, so maybe to help us, let's take a look at some numbers in here. So we'll say this is 3. Actually, instead of using 3, we're going to use 3, 4, and 5. That's a proper right triangle. So for sine x, what it is, sine x equals our opposite, which is 4, over our hypotenuse, which is 5. Perfect. Okay, so if we took that one step further, sine x equals 0.8. Excellent. Now that doesn't really mean anything to you right now, but we can totally solve that. Now to solve it, I need you to take a look at your calculators. And you're going to be using this calculator for every single question that you do for everything related to triangles, because you can't do any of it in your head. So what you need to do is you need to decide, are we solving for an angle or are we solving for a side? Well, in this question, what is x? X is an angle. So there are two things that you can use sine for. You can use sine to solve for a side. And I'm going to write don't shift or second. And what I mean by that is your calculator has a shift or a second function key. Don't press it. If you are solving for a side, you don't want to press a shift or second. But here we are solving for an angle. So we're going to use something called sine -1. And to get that, if we're solving for an angle, you need to press shift or second function to bring up that sine -1. Okay, so you might be using an app, you might be using a calculator, whatever you're using, you need to make sure if you're using a side, don't hit shift. If you're using it to solve an angle, you must hit shift. So what that's going to look like in this question here, we're going to get sine -1, 0.8 is going to give me my angle. So my angle x. And if I do that on my calculator, shift sine -1.8, that's going to give me an angle of 53.1 degrees. Okay? You need to make sure that you can do that on your calculator. So you might need to pause the video and figure out, okay, how do I do that? What are the steps I need to do in order to make sure that that happens? But that's a very important thing. You need to be able to take whatever decimal you come up with and then convert it into an angle. Okay? That is sine. The next one that we're going to look at is solving for an angle, or solving for a side length. So if I have my 53 degrees here, and I have my hypotenuse is 5, and I want to figure out, okay, what is this over here? Well, here, sine is a perfect way to do it. And why is that? Well, if we start by labeling our triangle, here's our hypotenuse, here's our opposite, and here's our adjacent, according to our angle of interest. We know that the formula for sine is sine of our angle, I'm just going to say x, equals opposite over hypotenuse. And now we can just go ahead and fill in what we know and what we don't know. So what is our angle here? Our angle is 53, so we'll put sine 53 equals opposite, which is x, over my hypotenuse, which is 5. Okay, generally a good idea before we do any of our calculations here or any of our multiplication, I would clean this up. So this sine 53, here, what are we solving for in this equation? We're solving for x, which is a side. So since we're solving for a side, do not hit that shift function. So when I do that, I get sine 53 equals 0.7986. And that equals x divided by 5. Okay, now I'm free to bring that up and multiply it by 5. So I get 0.7986 times 5 equals my x. And that gives me about 4, equaling my x value. So here we solved for the angle and we used sine -1. Here we solved for the side. So that's a little bit about how to use sine, and we're going to see a whole lot more examples of that. So sine, we know sine is good for opposite and hypotenuse. So it's called the SO. Next, we will move on to cosine. So cosine, if we have a right angled triangle like so, we can use that to solve for it. So if here's my angle and my angle is 37 and my side is this, I can use cosine to help me figure out some of the other missing sides. So let's go ahead and label our triangle. We have our hypotenuse, we have my adjacent, and we have the opposite here. So the formula for cosine of our angle x equals adjacent over hypotenuse. Okay, so let's go ahead and fill this in. Cosine of my angle, which is 37, equals my adjacent. I do not know that, so I'll just leave it as my adjacent, over my hypotenuse, which is 5. So now, what are we solving for? We are solving for a side here, so do not hit -1. So we'll do cosine 37 on our calculator. That's always going to give me a decimal. 0.7986 equals adjacent divided by 5. Multiply that 5 up. And we're going to get 5 times 0.7986. And that's going to give me an adjacent side length of pretty close to 4. Okay? And just like sine, we can use it to solve for angles as well. So why don't I do 53? And my adjacent side is going to be 4. And then I'm going to try to solve for this. So let's label my triangle here. Here's my hypotenuse, because it's opposite my right angle. Here's my adjacent. And here's my opposite, according to that. And we know our formula, cosine x equals adjacent over hypotenuse. And let's fill in what we know. Cosine of x, and my angle is 53, equals adjacent, which is 4, over my hypotenuse, which is x. We do not know what that is. So just like last time, let's clean everything up a little bit here. So cosine 53, if you do that on your calculator, let's see what we get. We are solving for a side. We do not want to put in that second function. So we get 0.601 equals 4 divided by x. And now we can just use our cross multiplication. So we turn that into a little fraction there for us. So we get 0.601 times x equals 4. Divide this side by 0.601, divide this side by 0.601, and we're going to get an x value equal to, let's see what we get, 4 divided by 0.601. So we get 6.65 for our x. Good stuff. Now let's look at one more where we are taking a look at solving for an angle. Okay, so if we have, this is our angle here, we have 5 and we have 3. Okay, and we also have 4. If we go ahead and label this, let's take a look at what we have. We have our hypotenuse, we have our adjacent, and we have our opposite. Now, we actually now have a choice. See, we could use sine is opposite over hypotenuse because we have the opposite and hypotenuse, or we could use cosine, which is adjacent over hypotenuse. And why could we use that? Well, we have the adjacent and we have the hypotenuse. So we can use either one, but since we haven't used cosine, I'm going to use cosine here. So we're going to use cosine of our angle, which we do not know is x, equals adjacent, which is 3, divided by hypotenuse, which is 5. Okay? We are solving for an angle here. At some point, we are going to have to use the second function key. So we get cosine x equals 3 divided by 5. You turn that into a decimal, we get 0.6. So now we're going to use our second function, and we get x equals cosine -1 of 0.6. So make sure you can do that. There is a little function on your calculator where it says either DEG on it or RAD. You never want to see it in RAD. You always want it in DEG, which means degrees. So sometimes that just means just need to reset your calculator. So always a good idea before you do this math to just make sure that you have it in degrees mode. So I'm going to take this, I'm going to use shift cosine of 0.6, and that's going to give me 53.1 degrees. So we have that figured out. So we had sine was opposite and hypotenuse. We have cosine is adjacent and hypotenuse. Now we just need to find the missing link, which is tan. If we have our triangle here, and we have 3, 4, 5, and I want to solve for this angle here, well, any sine, cosine, or tan would be a good bet, but let's investigate tan here. So we know that this is our hypotenuse, this is our opposite, and this is our adjacent. Tan, the formula for tan is tan x equals adjacent, equals opposite over adjacent. So all these things they're the exact same thing, just 3 different formulas. Okay? So tan of our angle, which we do not know, equals opposite, which is 3, divided by adjacent, which is 4. So these things can always be used in our right angles. Okay? So we have tan x equals 3 divided by 4, which is 0.75. And we are solving for an angle here, so we're going to have to use our second function. And we're going to get x equals tan -1 of 0.75. So when we do that, we get x equals 36.89 degrees. Perfect. Let's take a look at solving for a missing side. Missing side. So let's say my triangle has this. I have an angle of 62 and my side length is 110. I want to figure out what this is over here. So now we're going to have to start getting better at figuring out which ratio do we need to use, sine, cos, or tan. Well, it's always good to label these things. We have my hypotenuse, we have my opposite, and we have my adjacent. And this one involves my opposite and my adjacent. We don't know what the hypotenuse is, so we can't include it in our calculations. So which one uses opposite and adjacent? Well, we just said that formula right there has opposite and adjacent in it. So we have tan x equals opposite over adjacent. So let's fill in what we know. We know our angle is 62, so we'll fill that in for our x, equals opposite, which is 110, over my adjacent, which we do not know. So take your calculator. We are not solving for an angle here, so just use regular tan 62. That gives me 1.88 equals 110 over my adjacent. Now we'll cross multiply diagonally since we have a little fraction sandwich here. 1.88 times my adjacent side equals 110. Divide both sides by 1.88, and we get 110 divided by 1.88. That gives me an adjacent side of 58.5. So we have solved for an angle. We have solved for a side. This brings us to a very famous phrase in grade 10 math. So ka toa. And what is that? Well, this so means sine is opposite and hypotenuse. The ka is cosine is adjacent and hypotenuse, and then tan is opposite and adjacent. So it's an easy way to remember all of these formulas, and it's something a lot of students use to write on tests or just somewhere nearby so they can always refer to it. So how is this going to help us? Well, let's take a look at an example of a triangle and figure out which thing we need to use. So if I have an angle 14 here, and I have a side of 17 here, and I want to figure out what this is. So we need to decide which one of these three do we need to use. And I want you to take a second and try to figure that out. Which one would you use? So I'll give you a second here. All right, let's see how we did. So this is our hypotenuse, this is our opposite, and this one is our adjacent. So we need to figure out, in SOHCAHTOA, we need for sure two things. Which two things do we have here? Well, we know we have our adjacent. So we have this and we have that. Now, what's the other thing we need? We need our hypotenuse. So we are going to end up using this middle one here, cosine, because we have and need everything that it offers. So cosine x equals adjacent over hypotenuse. Cosine of our angle, which is angle 14, equals our adjacent, which is 17, divided our hypotenuse, which is x. And here we are not solving for an angle, so do not hit your second function. So we have cosine 14, that is 0.97 equals 17 divided by x. We're going to multiply that up. We get 0.97 times x equals 17. So we'll divide both sides by 0.97, divide by 0.97, and we get x equals 17 divided by 0.97. Gives us an x value of about 17.5 for our length of our hypotenuse. Okay? Perfect. All right, let's try one more, and maybe we'll make it a nice little word problem here. Let's say we have a basketball net, and here's my basketball net. Sweet. Now, basketball nets are about 10 feet high. So they're about 10 feet high, and they're going to cast a shadow on the ground. So here is my shadow, and let's say the shadow is very long because it's late in the day. My shadow is 14 feet long. I want to figure out what is the angle that the sun makes with the ground. So if you think about that, the angle that the sun makes with the ground, so we need to figure out what is this angle in here in order to make that happen. So what are we going to use? Well, if we have our SOHCAHTOA, what things do we have? What things do we need? Let's take a look. So let's label our triangle: hypotenuse, adjacent, and opposite. So we have our opposite, so we'll check off that, we'll check off that. And we have our adjacent, so we'll check off that, we'll check off that. Tan looks like our bet. So we're going to use tan x equals opposite over adjacent. So let's fill in what we know. Tan x, we don't know our angle, equals opposite, which is 10, over adjacent, which is 14. And that equals, if we turn it into a decimal, let's see, 10 divided by 14 is 0.714. So now we need to take it and turn it into second function because we are solving for an angle. So we get x equals tan now negative 1, 0.714. So we'll use our shift, tan negative 1.714, and that gives me an x of 35.5 degrees for our angle. And we are in good shape. That is how we use the basic trigonomic functions there. There are going to be a little bit of tricky ones, but nothing you can't handle in your homework. So make sure you are doing that. Okay? Good luck.